Hello everyone, so glad to see you here in cyberspace. I am a PhD student from Kyushu University, Japan, and two co-authors, Yuta Taniguchi and Shinichi Konomi, are also from Kyushu University, and the paper here is course recommendation for university environment. And different from MOOCs, the selection and recommendation in university is a complex task. And the challenge here is that there are many factors that students need to consider, like their interest and learning goal or career plan, the popularity of courses, and social aspects, like taking the same course with friends and get a high GPA and enough credits for graduation. Actually, students who enroll in the same course may have completely different orientations based on their reasons, which serves as different criteria for course selection. To make the point clear, a survey is conducted in our formal work to better understand student perceptions and attitudes for their course selection process. The result here shows that many factors may have an influence on their course selection, and the most important factor was interest. Also, if it's easy to get a good grade, and if it's easy to get a credits, are perceived to be important. So students have to consider all those factors together and try to make a trade-off. We also analyze the survey data to identify different types of students in terms of course selection motivations. And we use the K-mean clustering algorithm dividing students into three different clusters, and students of class 1 consider high grade as the most important factor, and they are inclined to choose courses that do not require too much effort or difficulty. And students of cluster 2 prefer to choose courses to pave the way for their future career, but they also want to make trade-off between high GPA and their interest. And students of cluster 3 seems to be challengers, and they may even take difficult courses if they are interested in them. To address this problem, we propose our hybrid course recommendation framework, which incorporates different criteria in a modular way to match the complex reality of the task. Moreover, in our approach, the criteria can be prioritized by students, and it is easy to interpret. And our framework includes three different parts based on our survey result: interest-based score, a timing-based score, and a grade-based score. And we use interest-based score to measure how interesting the course is for a specific student. And we think there is a strong relationship between student interest and the course categories. Um, so we extract student interest vector from their historical enrollment behaviors of different categories of courses, and we use interest vector to calculate the similarity of students. Then we utilize students' major information together with their similarity, and based on that, we calculate their interest score. And different courses may have different suitable time periods, like semesters in university. For example, courses can be taken by students of different grades, and the timing of taking a course has a strong correlation with students' GPA. So we think recommend the right course in right time is also important. And timing-based score is considered from two aspects in our research. Um, First, which semester is more suitable for taking this course? For a specific course, we sum up the number of enrollments for every semester and normalize all of the values. And second, which courses are popular for this semester? For specific semester, we sum up the number of enrollments for every course and normalize all of the values. Then we fuse them together to calculate timing-based score, so we could recommend right course in right time. And for the grade-based score, we use a collaborative filtering-based grade prediction method. Um, First, we compute the similarity between a student and senior students. Then we obtain the top K most similar senior students. We use that to predict the grade of course for the students. And then we combine these three parts together to generate the recommendation results for students. By taking those scores into account, the total score of student and course pair are determined. Also, we could change parameters to control the proportion of weights from different sources. In this study, we used a real dataset from our university that spans for 5 years, and the basic structure of the enrollment data is shown in this table. Each row of the course enrollment data contained an anonymous student ID, semester and department information, course information such as course name, instructor, credit, and course category. We conducted a series of experiments to evaluate our proposed method. First, we investigate the performance of our interest model with different weights of major information. Because each major has its own preference for courses enrollment, and students from the same major may take similar choice in course selection because they have similar background and knowledge level. Our result indicates that major information will improve the performance of the algorithm. We also investigate the influence of different factors. We set each parameter from 0 to 1 with a step size 0.05 to find the optimal combination. And the results indicate that recommendations that are aimed only at one factor are likely not to be satisfied by every student. And a hybrid system better matches different criteria of students, and it could provide explanations and user controls for different types of target students. We compared our method with two group popularity approaches. And the first one recommends the most popular courses in the department, and the second one recommends the most popular courses in the department and the academic level of the student. The results show that our framework performs well when compared with other methods. In this paper, we conducted a discussion about the underlying characteristics of the course selection of university students, and we proposed a hybrid course recommendation framework based on multiple features, and experimental results show our hybrid system better match the complex reality of the task. And for future works, it is interesting to find other factors that influence course selection of students, like social aspects and the relationship of course content. We also think the transparency of the course recommendation is important to increase students' trust in the system and improve the students' understanding about the recommendation. Thank you for your attention. I do be glad to answer any questions you might have.